it is 9 a.m. Wednesday the 25th, March 25th. This is our algebra session. Nobody's actually on yet, but I'm just going to go ahead and do my thing, and I will post this for people that might be having trouble logging in or couldn't attend at this time. So a few things to note. I wanted to do some announcements that are in Canvas, just run through them in the video, make sure everybody knows what's going on. The 7 a.m. class should be covering 6.1 to 6.3 right now. The 8:30 a.m. class should be covering 6.2 to 6.4, I believe. And again, those should all be in the modules. You've got the videos that cover the material, and the homeworks are open. Make sure that you have done the practice for each week, and all of the homework, and all of that is due on the 29th. All of that is due on the 29th, okay? So you've got a lot of stuff coming up in the next 4 days. Hopefully you've started it, because you're not going to be able to probably sit down on the 29th and do all of it without going crazy. So we're going to spend, let's see, a few more announcements. The 7 a.m. class has a test that I think is coming. I have to go back and look. I think today was going to be review day and Monday was going to be the test. That's going to be a project packet instead. So your test 3 is going to be a project packet. So that's going to be like a take-home test. I threw in some kind of real-life problems so you can see how this stuff is used, rather than just regurgitating the homework. Give you some things hopefully that are interesting to work on without overloading you as far as work. So that's going to be open for like a week or so, probably starting on Monday, because you've got a lot of material to cover and homework to do and stuff like that. For my 8:30 class, test 2 is still pending, and I am hoping to have those grades to you absolutely no later than a week from today. Logistically, it's difficult because I've got to grade them in PDF form and then post them to you. And then also I have, this weekend I have my comprehensive exams for my degree, which basically decides whether or not I get my degree or not, and that's kind of a big deal. So this week I am prepping for my comps, and then this weekend are my comps, and then after that my life is going to be so much better. And I promise as soon as I get those comps turned in, you guys are my top priority to get those test 2 grades back to you. In general, if you're worried about grades, please don't stress about grades. My priority is to get you guys to pass with enough material that you will be okay in your other classes. Okay, so a lot of schools have gone to pass-fail. I kind of wish that we had gone to pass-fail, so that I could just get you all through passing. We didn't, but please don't stress about your grade. Make sure that you look in the announcements. You've got some options. They've extended the withdrawal, and they've also given you an option for something called an R20, which basically just suspends you for this class. There's no grade, no financial penalty, no nothing, and you just retake, but you got to retake the entire class. It's not an incomplete. You have to retake the entire class this summer. So really, that's a great option right there if you were struggling already and you were worried about passing this class. The R20 option is really great because you don't have to pay for it again this summer. You just have to start from the beginning and take it again. If you're doing okay and you're panicking about online, then let's just try to stick it out and do this together, and I think you'll be okay. All right, so we've got my 8:30 class just took a test, my 7 a.m. class has a test coming up, and then everybody is going to have another test and a final at the end. And we're still working on potentially ways to video proctor that or something like that. So I'll get that information to you as soon as I can. All right, let's see. So I think that's it for announcements. Keep an eye on those modules, keep an eye on the announcements, and make sure you watch all of the due dates. I'm trying to not send out too much information, but at the same time I want to make sure everybody knows what's going on. So make sure that you're paying attention to the due dates on your own. All right, so let's go through, I'm just going to go through like one of each problem. Let me see if anybody's joined the call yet real quick. I can't see it. No, it looks like it's just me talking to myself. All right, guys. Okay, so 6.1 was composite functions. Hopefully the video was clear to you on this. Let's just work through another one together. Maybe seeing it a couple times will help. So let's do these color-coded. Let's say we have f of x equals 2x plus 3, and let's say that we have g of x equals 4x minus 1. Alright, so the first question is f of g, written that way, which is the same as f of g written that way. Okay, so this is just a different notation, but it means the same thing here. And we have kind of seen this before. We've seen function inside of a function. We see that g of x is on the inside, so I can replace that. I can take what g of x is and put that on the inside. Okay, so g of x is 4x minus 1. I take that and I put that into f. So that means anywhere there was an x, it's going to become 4x minus 1. So we're going to get 2 times, actually let me do this in blue, 4x minus 1 plus 3. Okay, so hopefully you can see that g is going into f right there. G is going into f. So we see g on the inside of f. And then you clean this up a little bit, 8x minus 2 plus 3. I just distributed here. And we get 8x plus 1 for our final answer. Okay, so f of g of x, g is on the inside, g goes into f. We could also do g of f. So this is g of f of x, and this time we see that f is on the inside here, so we would write this as g of, and let me erase my arrows now because we're going the other direction. Okay, so now f is on the inside, and f is 2x plus 3. So f is the same as 2x plus 3. 2x plus 3 is going to go into g. So anywhere there was an x is going to become 2x plus 3. And we're going to get, alright, so we're going to have 4 times 2x plus 3 minus 1. So 2x plus 3 is going right here. 4 times 2x plus 3 minus 1. Alright, so what do we get here when we clean this up? We're going to distribute 8x plus 12 minus 1, and we get 8x plus 11. Okay, so that's the basic idea there. The biggest mistake for these is getting them backwards, putting g into f or f into g and doing the wrong direction. So you want to make sure f of g, g is on the inside, g of f, f is on the inside. You do not need to write out all these steps. I'm trying to be super clear here. You don't need to write all these steps, but do be really careful that you're putting the right function on the inside, because getting these backwards is pretty easy to do. All right, let's do one of these where they give us a bigger function, and they want us to break it down into 2 smaller functions. So let's see, I'm trying to remember what we did before. Let's say we've got cube root of x plus 2. Okay, whoa. Alright, so we're given this big function h of x, and it's kind of complicated. And we want to find f and g so that f of g is equal to h. So basically we want to break this down to two smaller functions, so that when we compose them, it's going to be equal to our bigger function h. And we've seen this before with graphing, where we looked at the outside function and the inside function. So when you look at this, you would say this is a cube root graph, shifted left 2. You should remember that from our graphing stuff. So it's the same idea here. You're looking at the outer function and then the inner function. F is going to be on that side, g is going to be on the inside, just because of the way this is set up. So f is the outer, g is the inner. So the outer function, oops, let me put an x in here. Okay, the outer function is the cube root function. So the outer function is the cube root, and I need to put something here just as a placeholder, so I put x. Okay, because remember when we compose it, it's going to replace x. So the outer function is the cube root. I just put in the x as a placeholder. And then the inner function is the stuff that's on the inside. That's the x plus 2. So the outer function is cube root. The inner function is x plus 2. If we were to compose them, g would go into f. It would replace x. And we'd get cube root of x plus 2, which is the same as h, which is what we wanted. So this is like the check step. And we know that these do work as our composition. Okay, so that's the basic idea there. Let me see where I'm at. I got 5 minutes. I can only record in 15-minute increments. So let's go ahead and start 6.2. All right, in 6.2, the first thing that we talked about was one-to-one. So remember, functions are one-to-one if they pass the horizontal line test. We had the vertical line test for functions, and we've got the horizontal line test for one-to-oneness. So if we have, let's say that we have something like this. Okay, so before we said, is it a function? Is it a function? No, let me write that out. Okay, is it a function? And we would do the vertical line test. And if a vertical line hits twice, that means that we have one x going to two y's, and that would be a no. All right, let's try another one. Let's say we've got a parabola, and we want to know, is it a function? So we do the vertical line test, and it only hits once. No matter where we draw that vertical line, it only hits once. So yes, it is a function. Is it one-to-one? We do the horizontal line test, and it fails the horizontal line test because we hit twice. So it is a function, but it's not one-to-one. All right, and then looking at a cubic graph, looks something like this, and we want to know, is it a function? And we do the vertical line test, and we say yes. And we want to know, is it one-to-one? We do the horizontal line test, and it only hits once. So no matter where we draw the vertical line or the horizontal line, it only hits once. And so yes, this one is one-to-one. Okay, so we're looking at vertical line test for functions, horizontal line test to determine if it's one-to-one. All right, I'm gonna have to pause this and start a new video, so let's go ahead and do that.